Like, what do I look for?
Okay, so let's take a look at number 6, and then we'll go on to number 7. So what I did, my table is already filled in here, so it's a little misleading. What you want to do is I looked at, it gave me 2 points. It gave me that X and Y pair, and it gave me that X and Y pair. So from those 2 pairs, I can find the slope. So I subtracted my Y numbers, 31 minus 25, and then I subtracted my X numbers. Okay, so let's do that. Let's do the second problem here. Example number 4. Again, it gives us 2 points. So we should be able to find our slope. What's our slope going to be for this one? 3. So I would do 71 minus 83. I subtract my Y numbers.
Do you have another copy of this?
I don't know. Every time X goes up by 1 step, my Y's have to go down by 3. So here X goes up by 1, Y should be 80. And then I subtract 3 again, I get 77, 74. I subtract 3 one more time, I would end up at 71. That does seem to work. Questions on that? Okay, on to the last problem then. It says total spending on Father's Day gifts was $9.8 billion in 2010 and has increased by about $0.4 billion per year since then. Let S be the annual total spending in billions of dollars for Father's Day gifts at T years since 2010. Part A, it asks, is there an approximate linear relationship between T and S? Well, your instinct should be the answer is yes, because that's what we're talking about. So I'm going to put yes. And then, of course, we have to explain why. So why is it reasonable to think that it's a linear relationship?
Constantly, every year, it goes up $4 billion.
Each year, spending goes up the same amount, $0.4 billion. So yes, spending increases at $0.4 billion each year. So what is that number, $0.4 billion? What's another name for that? That's slope. How do you know that's the slope?
Because it's per year, that's how I remember.
Because it's per year. It also tells us how much we're increasing every year. That's our slope. Our slope tells us how much we increase or how much we decrease.
So the slope would be 0.4 over 1.
So the slope would be 0.4 over 1. That's right. $0.4 billion per year. Normally when we divide by 1, we don't write the over 1, but you can if you want to. Yep. So this would say we go up 1 year, spending goes up $0.4 billion. If the relationship is linear, determine the slope. We just said this, didn't we? The slope is 0.4. And we just said what that number means. What does that number mean?
$4 billion every year.
Spending goes up $0.4 billion per year. What is the S-intercept of the model? Okay, so S-intercept. That would mean that T is 0. So what year is year 0?
2010.
Year 0 was 2010. So in year 0, in the year 2010, how much was spent on me? 9.8 billion. So it would be 0, comma 9.8. And it means what I just said. In 2010, $9.8 billion was spent.
So in order to find that, on here, I plugged in 0. That's how you do it every time.
If I ask you to find the S-intercept, that means t has to be 0. If I ask you to find the, it's hard to just make up a letter. What if I tell you to find the x-intercept? How do you always find the x-intercept?
Y has to be 0.
Y has to be 0. How do you always find the y-intercept?
X has to be 0.
So no matter what thing I ask you for, if I ask you for the blank intercept, it means the other letter has to be 0. Correct.
So I can just plug them in.
Well, we don't have an equation yet, though, do we? Correct. If we have an equation, that's how you're going to do it. You're going to plug zeros in. Well, and that's part D. Find the equation.
Okay.
So, what's the equation?
9.8 plus 0.14.
Okay, I would write it as 0.4t plus 9.8, although your answer is correct also. And the reason I'm writing it this way is I'm thinking we usually write y equals mx plus b, except I'm not using y, I'm using s. M is my slope, that's 0.4. I'm not using x, I'm using t, and b is 9.8. If you were to write s equals 9.8 plus 0.4t, that's of course correct also and would receive full credit. I usually write it in mx plus b form. And finally, it asks, predict total spending for the year 2017.
12.
And how did you get 12.6?
I took the equation 9.8 plus 0.4 and plugged in 7.
You plug in t equals 7. That's exactly correct because we're starting in 2010. 2017 would be 7 years later. T equals 7.
But don't you have to add the 9.8 billion to that?
Yep, so it's 9.8 plus 0.4 times 7. Or, of course, it's, if we had done written the other way, 0.4 times 7 plus 9.8. Either way, you grab your calculator, 0.4 times 7 plus 9.8, and we get $12.6 billion. Questions on that?